This is number 57 in chapter 11. It's looking at physical properties and which one is going to have a higher or lower physical property between two molecules given their forces of attraction. And so the question reads, in each pair of compounds, pick the one with the highest vapor pressure at a given temperature. Explain your reasoning. So we want the highest vapor pressure. And remember, that's the same as saying lowest boiling point or weakest force of attraction. So with highest vapor pressure, we're looking for which one is going to have the lowest boiling point, and that really is identifying which one is going to have the weakest force of attraction. And so for the first one, we have Br2 versus I2. Both of these are examples of dispersion forces. Both of these guys have no molecular dipole. And so since they are the same type of force, it's really a question of molecular mass. And so since the molecular mass of Br2 is less than the molecular mass of I2, that is why bromine will have the highest vapor pressure, because dispersion forces increase with increasing molecular mass. So that means I2 would have stronger forces of attraction or a lower vapor pressure. Part B looks at comparing H2S versus H2O. And so if we draw each one of these molecules, we see we have a very similar structure. Both of these are tetrahedral electronically and bent according to their molecular geometry, but they have different forces of attraction. With H2S, we're really looking just at a dipole-dipole force of attraction. Both of these guys pointing towards the sulfur, essentially, with those bond dipoles creating a molecular dipole pointing down to the right. With H2O, we see that we have an OH, and so this is an example of hydrogen bonding. So remember, hydrogen bonding for us only is going to deal with alcohols and carboxylic acids. Those are groups that contain O and H. We also have to remember amines, N and H, as another example, but sulfur does not fit into that criterion. So H2S is a molecule that just has dipole-dipole forces, while H2O is actually one that has hydrogen bonding forces, again because we have that oxygen present. And so as a result, hydrogen bonding is the stronger force. So that means our dipole-dipole is going to be weaker of the two forces, and as a result it's going to have the highest vapor pressure as a result. So with part B, it's realizing that one of these molecules, H2O, is hydrogen bonding, while the other one, H2S, is only dipole-dipole. And lastly, part C is looking at NH3 versus PH3. These guys both have a very similar structure. Both are tetrahedral electronically. Both are trigonal pyramidal and molecularly. So we end up with these two structures. Again, we have molecular dipoles in both cases, but in the case of pH3, we just have a molecular of dipole or dipole-dipole forces of attraction, while with NH3 we now have again that prerequisite structure for hydrogen bonding. And so remember, our structures that we have to remember for these guys are our carboxylic acid, our alcohol, and our amine. And so if we see these different types of groups, we have to immediately know that these are hydrogen bonding groups. So as a result, the NH3, the hydrogen bonding, this guy has the stronger forces of attraction, and so that means our pH3 is going to have the weaker, and it would have then the highest vapor pressure as a result of having the weakest forces of attraction. That is number 57.